We're finally ready to learn about why we care whether two terms happen to be like terms or not. Why we care that two terms have the same letter part. The reason why we care is because if two terms happen to be like terms, it allows us to combine them, which combining is a little bit of a misleading term. What we really mean when we say combine is add or subtract. Add or subtract. Now, how does this work? Well, to add or subtract like terms, we add or subtract the coefficients and keep the letter part, or keep the variable part. So the procedure works something like this. If I was to add, for example, 5x and 11x, I would say, well, I recognize that these are like terms, right? Because they have the same variable x, right? The variable is the same. Well, what am I supposed to do first? Add or subtract the coefficients. It says add. So what are my coefficients? My coefficients are 5 and 11. I add that. And I keep the letter part. I keep the x. And so 5 plus 11 is 16. We have 16x. Notice that it makes perfect sense why this would be acceptable, because x times 11, x times 5, if we wanted to use the distributive property, gives us the 5x plus 11x. Think of it as undistributing the common factor x. Now, while the distributive property and distributive property in reverse, it helps you understand why the rule works. What you really should focus on is how to apply the rule, which is add the numbers, add the coefficients, keep the variable, keep the x. Let's go through a few examples. So first example, 7x plus 2x. Pretty much the same as what we went over on the last slide. We have like terms, so we just add the coefficients. 7 plus 2 is 9. And we keep the letter part, the x. The answer is 9x. Let's take a look at example 4. 7x minus 5 minus 2x. Now, let's look at this one a little bit more carefully. We have our like terms, 7x and negative 2x. Notice I can add them out of order because all of this is addition. Even when it says subtraction, it's addition, right? I can think of it as 7x plus negative 5x plus negative 2x. The order doesn't matter at all. I just see that I'm adding my like terms. Well, what is 7x minus 2x? 7x minus 2x, 7 minus 2 is 5. Keep the letter part x. And we also have a minus 5. We can't really combine it with anything, so it's going to be part of our answer. The answer is 5x minus 5. Let me get rid of all of the notation and run through it a little bit faster one more time, just so that if you're still confused, you can see how it works. These are my like terms. Looking at the coefficients, 7 minus 2 is 5. Keep the letter part x. And we still have the minus 5 we didn't do anything with, so it stays in my answer. The answer is 5x minus 5. Let's go to the next example. Example 5. Well, I'm adding and subtracting a bunch of things. We have like terms, 4x and minus 5x. So 4x minus 5x, let's do this on the side. 4 minus 5 is -1, and we keep the variable part x. Now, remember that when you multiply something by 1, it really doesn't change its value. So the simpler way to write -1x is just as -x. We don't have to write the 1, we know it's there. Now, we also have these numbers, 3 and 10. We can combine those as well, and 3 plus 10 is 13, positive 13, so plus 13. This is our final answer, -x plus 13. Notice in this example, as well as the previous one, all of the terms that we are adding are not like terms, right? The -x and the 13 are not like terms. It means I can't simplify this addition and subtraction problem anymore. I'm going to leave it as it is. One more example, 7x minus 7x. This one is not particularly complicated, but it's a source of simple errors, so let's talk about this. Well, what is 7x minus 7x? There are some people who say, well, 7 minus 7 cancels and you're left with an x. The answer is x. And that's not entirely true, because 7 minus 7, we don't really say it cancels. 7 minus 7 equals 0. So what you have is 0x. And 0 is a number, it's not an empty space. When you multiply 0 by x, well, 0 times anything is just 0, right? Like 0 times 1 is 0, 0 times 2 is 0. It doesn't matter what x equals, 0x is 0. So the answer is just 0. All right, so this is how we combine like terms, which is really the big new part of the second assignment, as you're going to see. And the next video is going to talk about simplifying more complicated expressions which require both the distributive property and like terms.